Today we're going to take a look at the second day of 14.2. But before we start, I want to remind us what these z-scores are that we calculated yesterday. That is the number of standard deviations, SD, from the mean. And we can either have positive and negative. So when we had our normal curve yesterday, our mean was in the middle, and we had standard deviations above. There was 1, 2 standard deviations, or we had them below the mean. But what we're going to be working with today is standard deviations in the middle, maybe 1.25 or 2.25. So if you take a look at the chart I handed out here, see if we can find that. This is a table with all of the ones in between, not the 1, 2, 3. We know 1, 2, and 3, 68.3, 99.5, 95.7, excuse me, and so on. But here's for some of the other ones. So if we take a look here, if it's negative 0.34, so below the mean, so if we wanted to draw a picture of this one, let's say here's that, mean, negative 1, 2, 3, 3.4. Standard deviations. The area before that is 0.003, so 0.03%. But when you take a look at this table here, it covers all of them. If you had, 1.6 was your standard deviation and it's a positive one. And let's do 1.6, you'll see here, we can go 1.63, so 1.6.03. So if we had our mean, and we went out 1.64, the area underneath that is 94.84% of the data, 0.9484. So it's a little bit different than yesterday because we're talking about all the area before it, not the area in between these two standard deviations. So if we take a look at this first example here, we want to find the proportion of observations from the standard normal distribution that are less than if we had a z-score of negative 1.25. So here's our mean. Negative 1.25 would be right about here. Standard deviations, and we want to know this area. So all we need to do is go to our table. Let's see, go back up to negative 1.25. Let's see, and remembering it's 0.1. So negative 1.25, negative 1.2, this was 0, 0.01, 0.02, 0.03, 0.04, 0.05, negative 1.2, 0, 1, 2, 3, 4, 5. We have it right there. So 0.1056, or if you want, we could switch it to a 10.56%. Either one is just fine. The next one is greater than 0.81. So here's our mean. So here we have 0.81 standard deviations. Now, our chart tells us what's underneath here. But what we want is greater. This is what we want. So let's see what this chart tells us. If we go to 0.81, let's see. Here we go. 0.8, 0.81 is right here. So we know the area in the pink here is 0.7910. So to get greater than that, well, 1 minus 0.7910, because 100% is underneath, is 0.2090. Or we could say 20.9%. The next thing it asks us is we want to find the proportions of observations that are between these two. So again, here's our curve again. Here's our mean. And we want negative 1.25 standard deviations and 0.81 standard deviations. We want this area right in the middle. Well, we can use the information from this previous problem. We know that less than negative 1.25, we know that this area from here to here is 0.1056, And we also know that from here to 0.81 is 0.7910. So we can see to get this pink value, we just need to subtract those. 0.7910 minus 0.1056. And if we subtract those, let's see, 0, 10, 4, 0.6854 or 68.54%. The last one we're going to look at, we're going backwards. We want to find the z-score that corresponds to the 90th percentile. So we know our mean, and we know that's the 50th. So up here is the 90th percentile somewhere. So we want to find what z-score that is, where underneath here is 0.9. So we're looking for the z, what equals 0.9. So we'll go back to our chart here. Let's see, where did that go? And we're looking for 0.9 in our percentage here. So let's see, 0.85, 89, 0.8944, 8962, 0.8977. So this one is pretty close. So is that one. Well, this is fairly close too. So we have to decide. It's around here, so which one of these is the closest? Well, this one's 0.002 away. This one's 0.0003 away. This would be 0.0015. So right here is the closest to 0.9. And if we follow that back, so that's 1.28. So our z-score that gives us closest to the 90th is 1.28.